Hey everyone, welcome back to SyntaxGrid, your space to learn data science and machine learning with clarity and code. In our previous videos, we explored supervised learning algorithms, covering both classification and regression techniques like k-nearest neighbors, naive Bayes, support vector machines, logistic regression, linear and lasso regression, decision tree, and random forest. If you missed any of those, be sure to check them out. Links are in the description. Today, we're starting a brand new chapter, Unsupervised Learning. And we'll begin with one of the most popular clustering techniques, k-means clustering. In this video, we'll break down k-means by covering 1. Definition and purpose. 2. Mathematical expression and objective function. 3. How the k-means algorithm works, step by step. 4. Purpose of clustering in ML workflows. So, let's dive right into it. 1. Definition and purpose. K-means clustering is an unsupervised learning algorithm used to group unlabeled data into k distinct clusters based on similarity. Its main purpose is to identify patterns or groupings within a dataset, especially when we don't have predefined categories or labels. The idea is simple but powerful. Group data points in such a way that those within the same cluster are more similar to each other, and those in different clusters are as different as possible. K-means does this by creating k-centroids, one for each cluster, and assigning each data point to the nearest centroid based on a distance metric, usually Euclidean distance. This technique is widely used in exploratory data analysis, EDA, customer segmentation, anomaly detection. 2. Mathematical expression and objective function. Now let's dive into the math behind k-means. Don't worry, I'll keep it simple and intuitive. The core idea of k-means is to minimize the distance between each data point and the centroid of its assigned cluster. This is done using an objective function, also called the distortion function, or within cluster sum of squares. The formula looks like this. It adds up the squared distances between each point and its cluster centroid. For all k-clusters, the goal of k-means is to find the cluster centroids that minimize this total distance. This ensures that clusters are compact and well separated. 3. How the k-means algorithm works. Step by step, k-means follows a simple and repeatable process to form clusters. Here's how it works, step by step. Step 1. Initialization. Choose the number of clusters, Ka. Randomly select k data points from the dataset as the initial centroids. These centroids will be the center of the clusters, at least for the first iteration. Step 2. Assignment step. For each data point in the dataset, calculate its distance to each centroid. Assign the point to the nearest centroid's cluster. This forms k-clusters based on proximity. Step 3. Update step. Recalculate the centroid of each cluster, which is simply the mean of all the points currently assigned to that cluster. This new centroid represents the updated center of the cluster. Step 4. Repeat. Go back to the assignment step. Reassign points to the new centroids. Continue this loop. Assign, update, reassign until the centroids stop changing or a maximum number of iterations is reached. K-means is an iterative algorithm that eventually converges when the cluster assignments stabilize. Next, let's look at where clustering fits into the broader machine learning workflow. 4. Purpose of clustering in machine learning workflows. Here's what makes clustering, and k-means in particular, so useful. Unsupervised pattern discovery. Clustering helps us discover natural groupings in the data without any labels. It's used in exploratory data analysis, EDA, to better understand the dataset structure. Preprocessing for other algorithms. Cluster labels can be used as features in supervised models. For example, grouping users by behavior before feeding into a recommendation system. Anomaly detection. Clustering can help spot outliers, data points that don't belong to any meaningful group. Dimensionality reduction and visualization, used in combination with PCA or TSNE to simplify and visualize high-dimensional data. In the next video, we'll cover the differences between k-means and other clustering algorithms its real-world applications, and the pros and cons. So stay tuned, and don't forget to check out our other machine learning videos on the channel to strengthen your ML foundation. Thanks for watching SyntaxGrid. See you in part 2.